Solve the differential equation 32 plus x to the fifth dy over dx equal to x to the fourth cosine y. Cosine squared y, where y is equal to 0, with x is equal to 0, giving the answer in the form of y equals f of x. So we have a differential equation. How are we going to start off to solve this? Separate our x's and y. So this is a separable differential equation. Okay. So by separate, what do you mean?
Well, I started off by moving the 32 plus x to the other side by dividing it. So that made I put all the things. Okay. So you divided by 32 plus x to the fifth. The right side is divided by a cos squared y to the side. To give us dy dx times 1 over cos squared y.
Okay, so essentially you divided both sides by 32 plus x to the fifth, but then you also divided this side by cosine squared y.
Yes, that way it's over there.
Well, what is that? What does that simplify down to be?
Secant squared y.
Thank you. So this becomes secant squared y dy over dx is equal to x to the fourth, 32 plus x to the fifth. Now what? Yes, we can take the integral of both sides. With respect to what? Dx. This allows the dx's on the left side to cancel out. So since we're just taking the integral of secant squared y dy. And then over there on the left-hand side, we're going to have to do a little what? To integrate this. Not by parts. This one's a U-substitution one. So if I do U-substitution, I'm going to make U what? Yep, because what's du? 5x to the fourth. And then since we're trying to make it equal x to the fourth, that means that we would have to divide by 5, right? So when we actually integrate this, we're actually going to be integrating space for this. 1/5, 1 over 5u, or 1/5 times 1 over u du, right? What's the antiderivative of 1/5, 1 over u du? ln of u times 1/5, because remember, any constant can always be pulled out of the integral, so it's technically just the integral of 1 over u. So that's 1 over 5 ln of u, absolute value, of course, then plus c, right? But I need to plug that u value back in. My u was 32 plus x to the fifth, so this becomes 1/5 ln absolute value 32 plus x to the fifth plus c. That's the right-hand side. What's the left-hand side turn into? What's the antiderivative of secant squared y? The tangent y. So all this is equal to so then from here we solve for y. So y is going to equal what? Exactly. Arctangent, or basically the tangent inverse of 1/5 ln 32 plus x to the fifth let's see. Now we got to solve for c. Yep. So we separated our variables, got our y's on the same side, got our x's on the same side. Then we took the antiderivative of both sides, doing U-substitution for the right side, and then we solve for y. So now all we have to do is find our constant c, and then from there we'll be able to essentially solve, right? All right, so how do I solve for c? Say again? Yes, I'm gonna plug in 0 and 0 because I was told originally way back up here, when y is equal to 0, x is equal to 0. So I'm gonna use this open space that I have right here. And I'm gonna plug in 0 for y. Now I got arctangent or tangent inverse, 1/5 ln 32 plus c. What is that? So we got
Negative 0.693.
Oh, did you do the arctangent?
No,
Yeah, you have to do the
that's the.
arctangent. I got a 34.7.
You did what?
okay.
What is that?
So c is equal to 0.606. So we can plug it back in. And oh, was that plus or minus?
It was minus. That's the answer?
And one more.
Okay.
How should I start this one?
Divide by x to the third.
So-
Isolate the divide by x.
So then that gives me dy over dx plus what?
So 4y over x.
4y over x, because the x squared would cancel out with 2 of the x's in the denominator, equals what?
E8x to the.
There we go. Now what? Huh? Make 4y over xv.
Before b, is when you plug in b from y equals dx.
So you're saying this is a homogeneous one?
I didn't. That's what I'm thinking about.
Okay, so some did homogeneous, wait, some did homogeneous, some did integrating factor.
Yeah, this is in the structure where integration of.
So this is the integrating factor one that you want to use. Because remember, integrating factors are in the form of dy over dx plus p of xy equals q. Okay, that particular form, that was from Tuesday. All right. So if you do this, then you need your integrating factor, your I, which is equal to e to the integral of p to the x dx. What's p to the x? What will be p to the x? Or p, not p to the x, p of x. It would be 4 over x, because it's technically times y. What's the antiderivative of x of 4 over x? for ln of x. You said wouldn't that just be 4?
Yeah.
Not 4.
4x.
4x and
Not 4x.
x to the 4.
X to the 4.
Yeah.
So remember, you apply your laws of exponents. E to the ln cancels out, so I is equal to x to the 4th. Okay, so we have that bit. Let's head back over here. So how can I use that integrating factor with what I already have that's in like the reddish brown color?
And then do d over dx for or x to the 4
X to the 4.
equals that x to the 4 again.
Like this. Missing something. No, I see.
Y.
I'm missing a y somewhere.
Sorry. Oh, right, by the x to the 4.
Right by the x to the 4th. Very good. Okay, here the x to the 4th on the right side do what? They cancel out. So I really just have e to the 8th over e to the 8x over here. And then what about the left side? No, gotta do something with that d over dx. What I need to do? If I integrate it back here, then essentially I'm just integrating this, that goes away, and you're just left with this. And so what's the inside root of e to the 8x? 1/8 e to the 8x plus c. Keep going. Divide by an x to the 4th. So technically,
I think you're going to use the 8 over 8 1.
well, we could have done that. Well, we're not. Well, yeah, I mean, we are. We're gonna solve for y, but do you want to just plug it in now, find c, and then solve for y? Like, we're gonna get that in once we get it solved for y, and then we're gonna find c using the.
I didn't see the x to the 4th still there. That's what
Oh my goodness. Alex. Divided by 8 earlier, now we got. Okay. All right. When I divide by x to the 4th, what am I gonna have? What's my numerator?
E.
Yeah.
E to the 8x
And then 8 times x to the 4.
and c's on its own.
Mhm.
All right, good. So now let's find c. Oh. Already? Y was e to the 8 over 8.
Yeah.
U. And x was what? 1. So, yep, c is equal to 0. So then y is just equal to. No. Is this all y'all? So from the homework, which means that dy over dx is equal to what? So this was homogeneous? Okay. All right, then what? How will we tackle this over here?
Yeah, right. If you take out, what I did, I think, was I took out I didn't write one with that.
Well, how'd you write yours? I wrote what you said.
So I set. wait a minute. I set y is equal to vx, so eventually when you do product rule on your side, you should get x to the derivative of v plus v is equal to v minus 1 over 1 plus v.
So this V. Because if you're taking the derivative of this, then this essentially would be what it is. So the first times the derivative of the second, which is just V, and then the second times the derivative of the first, which would be x dv over dx.
Well, the first, okay, I should explain it better. So I substituted y, like I substituted vx into that equation. So then what I ended up doing was taking out, I ended up taking out a.
So you plugged it in here.
Yeah.
Okay. And you took out an x out of the top and the bottom. So my x's cancel out. Okay, then what?
You still have the other side too, so.
Essentially, we'll need both pieces, right? Then what do I have to do to, what can I substitute in? I'm gonna substitute that in that expression right here. The left side becomes this expression that we have over here. Okay. Then what can I do? Well, I have a lot of my v's on the right-hand side, right? Except for this one v over here. Can I move it over? Okay, so I got x dv over dx equals v minus 1 all over 1 plus v minus v. But in order to essentially be able to subtract these, I need a common denominator, right? Okay. So then my common denominator is going to be 1 plus v. So if I multiply this by a 1 plus v, that's going to turn into v minus 1 minus v squared. Right, because I'm trying to make it a common denominator. So I do this to the top and the bottom. Negative v squared minus 1, because my regular v's would cancel out. Multiply both sides by 1 over dv. Yeah. But then that's actually going to cause if I do that, if I multiply this by 1 over dv, this is going to cause my dv's to cancel out. So I'll have x over dx equals technically with the dv in the denominator. Can I have that? Have you ever seen dv in the denominator, dx in the denominator? No, normally they're side by side, which means they'll be technically over 1.
That looks really weird.
So then how I can fix it? How can I fix it? So essentially flip, right? So I can multiply both sides by dx, multiply both sides by dv, and then get the b's on the left side, get the b's on the right side. In other words, I'm literally just flipping both sides.
Yeah.
So
I
then that
was trying
turns
to
into,
figure out how to do that, because then you could take out the arctan.
I don't like this negative b squared minus 1. How can I fix that?
Oh,
I can take out the negative, which means I'll turn this into a plus. Okay. So now this looks a little bit more right. Now what can I do?
you could integrate.
I can integrate.
If you actually, what you could do is, you take off that 1 plus v, so it's like 1 plus v, and then 1 over v squared plus 1, because 1 over v squared plus 1 should equal arctan v.
Okay. And then integrate.
Mhm.
Okay. Integrating both pieces. Yeah. So left side would just turn into ln of x. Will be yeah.
Um,
What will I do here on that right side? Okay, so actually, instead of splitting it up like this, let's actually split. Well, first, let's take out the negative, right, out of the integral. And then let's separate the numerator with the denominator under both, like so. Because essentially they are the same thing. And then that way, when we take the antiderivative, we will have arctangent for the first piece. So I have negative arctangent b. Then here for this part, we're going to do a little bit of U-substitution. So then we'll make u b squared plus 1. That would make du 2v dv. This becomes 1/2 du equals v dv. So then when we take the integral, this ends up being 1/2 1 over u du, which will end up being 1/2 ln u plus c. So then that becomes plus 1/2 ln b squared plus 1 plus c. What does the left side turn into? The ln of x, absolute value of x. I'm gonna go ahead and switch the placement of the negative. So let's just make this negative ln of x equals arctangent v. So I can just drop that negative altogether. Plus 1/2. All right. Now that we have that, what should I do?
Substitute everything back into the v's.
Okay, what am I going to substitute back in for v?
Since
Y over x, and since back here y equal v times x, that essentially means that v is equal to y over x. So we can plug that back in for all of our v's. Shouldn't write so big. Y over x, right? So this would be y squared over x squared. And now, okay, so, oh, it's gonna keep getting smaller and smaller. So it's like, what I'm gonna do is I'm gonna actually take this, that's inside the absolute value, and I'm gonna make it into a common denominator by multiplying that 1 by x squared. So I can do that. All right. And then, let's see, what else can I do? I'm trying to solve. Let me try to solve. I'm trying to solve it here. Well, because I can't separate the y's from the arctan. And well, the only thing I want to be able to do is actually just solve for speed. It's the only thing I'll be able to do at this point. Yeah. So subtract over the arctangent. Subtract over the 1/2. And this is the most I'm going to be able to do because I can't separate that y from the arctangent. That's about as far as we can go. That's going to be the value of C.
So it's okay to leave it like that?
Mhm.
Okay.
This is as far as that we're going to be able to go.
We can't find very general solutions to that.
Yeah.
I think the sign was so.
So this was number 8. Okay, this was number 8. How'd you guys start? You subtracted that over? Okay. Mm-hmm. Divide everything by dx. So then that will give me these would drop. Now what? Could I well, every trig function has a y over x, right? So we could divide. This ends up being negative tangent y over x. This one turns into positive y over x cosine y over x. And then over here, I just have a dy over dx, okay? Oh, all right, I'm mistake. It does turn into 1. Thank you. So already we've taken that long starting problem to something quite smaller, significantly. So could from here, what, huh? I can use v. Yeah, I can make y dx, which means that dy over dx turns into v plus x dv over dx. Okay. Okay. This will turn into v, turns into vx over x technically. So then that just turns into just a v, right? Then over here plus negative tangent vx over x, which is just negative tan x v plus v equals v plus x dv over dx. Hey, what do you see? Subtract the v's. So we just got negative tangent v equals x dv over dx. OMG.
I am angry.
No, that's
Oh,
such an easy,
OMG.
that is such an easy integration.
I didn't even realize that the y over x was connected to the cosine. So we know that.
So
I what a simpleton.
should I move my dv over? All right. So I'm gonna multiply by 1 over dv. Right? Even though I hate doing stuff like that. It's so ugly.
Yeah, you told us not to do that.
I hate that. I mean, but it's essentially what I essentially am going to be doing is multiplying both sides by dx, dividing both sides by tangent v, and dividing both sides by no. And yeah, and then dividing both sides by x. So essentially like 4 lines, and then I'm gonna have to flip them again.
So we are allowed to do it.
Yeah, I will not say, I will neither confirm nor deny. Okay. So then, of course, I need to fix that, and that's gonna turn into dv. Let me fix that so it doesn't look like a u. dv over tangent v, or negative, and then this will be dx over x. One over tangent. But you know what? Tangent is sine over cosine. So when it's in the denominator, it's technically cosine over sine, isn't it? So this can actually be written as
When I do that on my surface flow, it's so satisfying when I get to derive over.
it's gonna be negative cosine v over sine v dv equals 1 over x dx technically. All right. Can I iterate now?
It looks fine.
All right, so let's do that. And turning it into sine, cosine over sine, because technically 1 over tangent is 1 over sine over cosine, so it flips. And then on the right-hand side, that's just gonna be our normal ln, absolute value of x. But over here, I can use, oh, that you're thinking derivatives. You can do U-substitution, right? Because what's the derivative of cosine? Or sorry, what's the derivative of sine? Sorry, it's cosine. So then this just turns into -1 over u du. So then this is just a negative ln of u or negative ln of sine v. And then couldn't I could do the e, huh? Well, first I need to move that negative up to the exponent, so this turns into ln sine v to -1. Then I can apply the e. So this turns into sine v to the -1 equals x plus e to the c, because technically both of them got raised up.
So you apply the e to both of the elements. Both of the elements.
No, it's times, sorry. It's be times, wouldn't it? I do the e, all of that's in the exponent.
Oh, I was just saying, even if it's still a constant.
Yeah. But it is e to the c. I mean, unless you change the variable altogether.
So we could just put EC.
Mhm.
So if I started to say like, set A equal to E. Oh, well, we're not.
So then this is be x. Replace. No, we'll make it cosecant.
So can we go ahead and make it cosecant, or do we have to do it that way?
More I think about it, back up there when the tangent was negative, we'd switch sides, and the ln on the other side would be negative. A little easier, but this doesn't matter, I don't think. So then we'll have cosecant y over x minus x equals e to the c. I did the e of both sides back here. I just didn't show it.
Oh, we just move that up.
Mhm.